Alright, so the first example that we're going to be working is one of a strong acid, strong base titration. So let's consider the titration of 15 milliliters of 0.2 molar hydrochloric acid with 0.2 molar sodium hydroxide. Okay, so we know that hydrochloric acid and sodium hydroxide react according to this equation. They react to form H2O liquid and sodium chloride. Okay. So during a titration, we know that the equivalence point is reached when the number of moles of base equals the number of moles of acid that are initially put into the solution. So the first thing that we're going to do is we're going to figure out what the initial moles of hydrochloric acid that is in the solution. So we'll start with 15 milliliters of our hydrochloric acid, and we'll convert this to liters and use our molarity to convert to moles. Units cancel, and we get a result of about 0.003 moles hydrochloric acid. So now we should figure out the volume of sodium hydroxide that will react with 0.003 moles hydrochloric acid. So by using stoichiometry from our equation, we know that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So we know that this 0.003 moles of hydrochloric acid is the same as 0.003 moles of sodium hydroxide. Use our molarity again, this time for sodium hydroxide. Convert to milliliters, and we find is 15 milliliters sodium hydroxide. So the next thing to do should be to find the initial pH of the acid. Since it is a strong acid, the concentration of our H3O+, which is used to calculate pH, is going to be the same as the 0.2 molar of hydrochloric acid. So our pH equals negative log the concentration of H3O+ equal to negative log of 0.2, which is about 0.699, which is very acidic. So now that we have this information, we can calculate the pH for any volume of base that we add. Since it is a strong acid and strong base, we already know that the pH at the equivalence point should be 7. So when 15 milliliters of sodium hydroxide are added, that'll be at the equivalence point, giving you a pH of 7. So what would happen if we added about 10 milliliters of sodium hydroxide? Well, that would give us something that will be below the equivalence point. So let's look at that. So if you take 10 milliliters of sodium hydroxide, you can convert that to liters and use the molarity to get moles. 0.002 moles of sodium hydroxide are added. Then we're going to use a BAA table according to this reaction. BAA stands for before addition, the addition, and then after addition. Now, since water in this case is a liquid, it's not a player in this reaction, so we can cross that out. So at the start, we have, from our beginning here of the 0.003 molars hydrochloric acid, we know that that's the same as the concentration of H3O+. So we have 0.003 moles and about 0 moles for OH. So then we add 0.002 moles from the sodium hydroxide. We don't add any, no H3O+ is added in this case. And then we subtract and get about 0.001 moles for H3O+. So now we should find the concentration of H3O+. This is in moles, so now we need to put it into terms of molarity. So the concentration equal 0.001 moles divided by the total volume of the solution, which is the 10 milliliters that we added plus the original 15 milliliters. We can convert this to liters and get a molarity of about 0.04 molar. This value, we can plug this value into the equation for pH, equals the negative log 0.04, which will give us a pH of about 1.40, which is still very acidic and thus below the equivalence point, which is what we expected. So now what would happen if we added something like 20 milliliters of sodium hydroxide? Well, we know that this is going to be past the equivalence point because the equivalence occurs when 15 milliliters of sodium hydroxide is added. So the first thing we need to do is figure out how many moles of sodium hydroxide are added. Well, we convert to liters and then use the molarity, and we get 0.004 moles of sodium hydroxide that are added to the solution. Again, we use our BAA table. According to this reaction, again, water is not a player. We get about 0 at the start. The 0.003 moles of H3O+ that we calculated earlier. In this case, we're going to add 0.004 moles of OH minus from sodium hydroxide. Now, in this case, we're actually going to end up with an excess of base rather than acid. So we can't directly use our conversion for pH. In this case, we'll calculate the concentration of OH minus. So we take our 0.001 moles and divide by the initial 15 milliliters plus the 20 milliliters that we added. Convert this to liters. And we get about 0.0286 molar. Now, using our concentration of OH, we're able to calculate the POH, which will be the negative log of the concentration of OH minus. So the negative log gives 0.0286, which is about 1.544. Now we know that the relation between POH and pH is that POH added to the pH will equal 14. So therefore, pH equals 14 minus the POH. Well, we have the value for the POH, so this value is very easy to calculate. We subtract, and we get that the pH is 12.456, which is very basic, just as we'd expect for something past the equivalence point.